So the butterfly theorem says that let M be the midpoint of chord PQ of a circle W, through which two other chords AB and CD are drawn. So two other chords AB and CD are drawn through M, which is the midpoint of a chord PQ. Let the point of intersection of AD and PQ be X, and the point of intersection of BC and PQ is Y. You have to prove that M is also a midpoint of XY. So I will draw a rough figure. So let me draw a rough figure. This is a circle, and there is a chord PQ, and there is a midpoint M for the chord M, and two other chords AB and CD are drawn through M. One chord is like this. This is A. This is B. One chord is like this. This is CD. So this is C. This is D. And then AD intersection with PQ is X. AD intersection with PQ, this is X. And BC intersection with PQ is Y. So now it starts looking like a butterfly, right? This thing looks like a butterfly. You have to prove that M is also midpoint of XY. M is the midpoint of XY. XY is this. Every question you guys will try for a bit, and then we'll discuss what are the ideas that are coming, and we'll figure it out. So to prove that M is a midpoint, what do we need to prove? We need to prove that this distance is equal to this distance, no?
Yes.
Okay. So one thing that everyone should do is maybe make a center for the circle. Let's say center for the circle is somewhere here, O. So we know that OM line is perpendicular to PQ because O is line joining center to the midpoint of a chord.
Yes.
OM is perpendicular to PQ. That we know. We have to show that. Wait, I couldn't hear you. Show that XM is equal to MY. So XM is equal to MY. How will you show? Like if you draw a dotted line like this, okay, I've drawn a dotted line. This is a common side for both these triangles, no? Common side is there, right angle is there. If I can show that the triangles are similar, then the triangle will be congruent, no? This triangle and this triangle.
Yes. So we can show angle MXO is equal to angle MYO.
Exactly. So if you can show either this angle is equal to this angle or this angle is equal to this angle, then your job will be done, no? Proving angle MOX is equal to angle MOY. If you can prove that, that will mean that two angles of the triangles are equal. That means they are similar triangles, and one side is anyway common, so it will be congruent. And then that will mean that this is true. So your target can be to prove that these two angles are equal. one hint that I can give is construct perpendiculars from O to AD and BC. So I can drop a perpendicular from O to AD, which is say here. This is 90. Let's call this point is R. Similarly, drop a perpendicular from this to this. Let's call this S. Okay. Then you have dropped a perpendicular from center to that chord, no? So that R and S must be midpoints of the chords.
Yes.
Perpendicular from center to a chord will pass through the midpoint of the chord. So as soon as you do this construction of these two perpendiculars, you know that AR is equal to RD, and you know that CS is equal to SP. These two things come. Now it is about finding some angles.
So we get a cyclic quadrilateral.
Correct. OMXR and OMYS are cyclic. That is obvious because two angles are 90-90, right? Opposite angles are 90-90. So OMXR and OMYS are cyclic. That means that MOX will be equal to MRX, right? So angle MOX will be equal to angle MRX. MRX angle is equal to same as angle MRA.
Yes.
And similarly, you have angle MS.
Angle MOY is MS.
MSY or MSC. Angle MSC is equal to angle MOY, right?
Yes.
You have these two relations from cyclic quadrilaterals. So even if you can prove that MRA is equal to MOY.
So or MRA is equal to MFC.
MRA is equal to MSC. MRA is equal to MSC. If you can prove, then also you're done, right?
Yes.
So your target is now proving angle MRA is equal to angle MSC. If you can prove that, then your MOX and MOY become equal,
So
right?
because DAB is DCB and
DAB is DCB, correct?
yes, and angle AMD is equal to CMB.
AMD is equal to CMB, correct?
So the in between angle RMA will be equal to CMS.
RMA will be equal to RMA. RMA will be equal to how much?
CMS. Will that be true? CMS.
No, directly that is not true. No, I am not sure how. Like, what are you saying? What is the logic?
No, if we can prove that, then
That is what we want to prove. So maybe some similar triangles will work if you think a little. MRA and CMS. Which triangles can you take? So AMR and CMS triangle. Let's just work on that.
yes,
AM
the same.
AMR. This triangle and CMS.
Yes.
This triangle. One angle is same. This angle is same, no?
Yes.
One angle is already same. So What else? If we know that it is a similar triangle, will be done. So can we prove similarity in some other way here? If we can prove similarity in some other way, we'll know that this angle should match this angle, right?
Yes.
MSC, MSC and MRA we have to prove. So let's look at the two triangles. First of all, we can say a simpler thing is triangle ADM is similar to triangle CMB.
Yes.
Why? Because ADM and CMB are opposite angles, vertically opposite angles, right?
Yes.
And this angle is same, right?
Yeah.
So ADM is definitely similar to CMB, and because of that, we get AD by AM. AD by AM is equal to CB by CM, right? AD by AM is equal to CB by CM, correct?
Yes.
And AD isn't AD is equal to 2AR.
Yes.
2AR by AM is equal to CB is equal to 2CS.
Yes.
So you are getting AR by AM. AR by AM is equal to CS by CM.
Yes.
That means ratios of opposite sides are same and one angle is same.
Yes. So, but is it the included angle?
That included angle, no? AR, AM, CS,
Yes.
CMC.
Yes.
So two sides are in ratio and one included angle is same. So triangle ARM is similar to triangle CMS, which means angle MRA is equal to MSC and MRA is equal to MOX and MSC is equal to MOY, right?
Yes.
MOX is equal to MOY and
Yes.
then XM is equal to MY.
Yes.
Everyone has followed. There are many steps.
Yes.
Yes, sir.
There are
So
many.
can you repeat it once?
Uh, repeat what once?
Can you just brief it once more, like everything?
So first, what we did we draw? We made a perpendicular OD OROS. OROS. Once you got, what we want to prove is to prove that XM is equal to MY. XM is equal to MY. To prove, we need to prove that MOX is equal to MOY. These two angles, if we get, then we will get by similarity in congruent triangles, we'll get that XM is equal to MY. Once we constructed the perpendiculars, we know that perpendiculars will be bisected, the chords will be bisected. So AR is equal to RD, CS is equal to CB. As soon as you got that, you can see that OMXR, OMYS are cyclic quadrilaterals because 90-90 degree opposite cyclic quadrilaterals. Now, because of cyclicity, you have these angles are equal. MOX, MOX should be same as MRX, MRX because same chord, and MRX is equal to MRA. MRX angle is same as MRA. Similarly, MSY is equal to MSC is equal to MOY. So to prove, we have to prove MOX is equal to MOY. We have got these two. So instead of proving that, we can directly prove MRA, MRA, and MSC. These two angles, if we can prove is equal, then we are done. To prove that, we note first that AMD and CMB are similar triangles by angle AA property. Once they are similar triangles, AD, you write the ratio of the sides. You got AR by AM is equal to CS by CM. Once you got these ratios, you know that this angle is same because same chord, same arc is subtending. The two sides are proportional and included angle is same. So therefore, triangle ARM is similar to triangle CMS. ARM is similar to CMS means angle MRA is equal to angle MSC, and therefore we have proved what we wanted to prove. So it is fairly clear, and each step you guys can also follow, and you guys almost also were getting it, so that's fine. Second one, this was the first thing. I hope you have written down what you needed to write. You need
Yeah.
to write the statement and brief ideas of the proof so that you can refer back to it later. So second lemma is, let ABC be a triangle with arbitrary points A dash, B dash, C dash, on sides BCCA AB respectively. Now you have to prove that the circumcircles of triangle A B dash C dash, triangle A dash B C dash, and triangle A dash B dash C intersect in a single point. This point is called the Michael point. This point is called the Michel's point, and this theorem is called Michel's theorem. So I'll draw a figure. So you have a triangle like this, A B C B C, and you have three arbitrary points. One is C dash here, one is A dash here, one is B dash here. You have to prove that circumcircles of triangle A B dash C dash. So 1 second. Triangles A B dash C dash circumcircle A dash B dash C circumcircle, and A dash B dash this. So these three circumcircles. So there will be a circumcircle like this passing through this. There will be a circumcircle like this passing through this, and there will be a circumcircle like this, which will also supposed to pass through one point. So there is one point through which all the three circles pass through. That is what you have to prove. This point is called the Michel's point, M. Basically, the job is to prove that circumcircles of these three triangles intersect in a single point. So the strategy to prove it is that assume say circumcircles of, assume M is the point of intersection of circumcircles of two of them, say A B dash C dash and A dash B C dash. Suppose that, assume that, prove that M lies on third circumcircle. So that will be enough to prove it. So which is A dash B dash C. That is the strategy. To prove that something lies on a circle, it is sufficient to take some angles and prove that it is a cyclic quadrilateral, no?
Yes.
Yeah. So suppose you want to prove that M lies on the circumcircle of A dash B dash C, it is enough to show that angle A dash C B dash, angle A dash C B dash plus angle A dash M B dash is equal to 180. If you can show that, then you have proved it, that M lies on the circumcircle of A dash C B dash. This is not a difficult question, because you can already assume this, no?
Yes.
Yes, sir.
So if you take this angle as alpha, this angle as beta, then this is a cyclic quadrilateral by assumption,
Yes.
this one. So this angle is 180 minus alpha. And similarly, this is a cyclic quadrilateral, so this angle is 180 minus beta.
Yes.
So this angle must be alpha plus beta, no?
Yes.
But you know that alpha plus beta plus C is already 180, no?
Yes.
Because it's a triangle.
Yes.
Triangle ABC is 180, so alpha plus beta plus 180 is already happening. So alpha plus beta plus this angle is 180. So M point also lies on circumcircle of
A dash C B.
A dash B dash C, right?
Yes.
So all the three circumcircles intersect at one point, and that point is called Michel's point. And there is a related idea. Everybody has understood this, right?
Yes,
Yes.
sir.
Yes,
So
sir.
there is a related idea, which is the third theorem, which is similar. So let ABC be a triangle with arbitrary points A dash, B dash, C dash on sides BC, CA, AB. The Michel point, this theorem says that the Michel point lies on the circumcircle of triangle ABC if and only if the points A dash, B dash, C dash are collinear. The Michel point lies on the circumcircle of triangle ABC. So obviously circumcircle, Michel point lies on the circumcircle, you have to prove. So this is a slightly different question if and only if the A dash, B dash, C dash are collinear. So collinear if they are, then one of the points must lie on the extension of the sides, no? So it should be, figure should be somewhat like this. So if you take this as A and this as B and this as C, your C dash must be somewhere here, and say B dash, A dash is here and B dash is here. So then it looks a little collinear. You have to prove that these two statements are equivalent if and only if, right?
Yes.
So A dash, B dash, C dash are collinear. Then let's draw roughly the circumcircles. Michel point lies on the circumcircle of triangle ABC. So let's draw first triangle ABC's circumcircle, which is somewhat like this. Circumcircle of triangle ABC. So okay, and Michel point lies on it. That means one of the circles for the Michel point was this triangle. One of the triangles was this triangle. A dash C B dash B, A dash C dash B, and one of them was A dash B dash A, right? No, A dash B dash A doesn't make sense. A dash A B dash C dash, A B dash C dash is one triangle. No?
Yes.
A B dash C dash. Then you have C dash A dash B, and then you have A dash B dash C. These three circumcircles. So it will be hard to draw, but I'll try. So there will be one circle like this. One circle like this. This is circumcircle of this one, A dash B dash C. Then there will be one circumcircle which will be very big because this is like this obtuse type of triangle. So I will just try to draw it like this. It is not fitting exactly, but imagine that it is correct. There is one like this, and the other one is this, this, and this. So the circle will be somewhat like this. You have to prove that this Mikkel point, the intersection point of these three circumcircles, is lying on the circle. This Mikkel point is M, let's say. This Mikkel point lies on the circumcircle of triangle ABC. So you can start off by saying let M be the Mikkel point of triangle ABC with respect to the 3 points A dash, B dash, and C dash. And you want to prove that M also lies on circumcircle of triangle ABC. You want to prove this from here. So, okay. So what do we know about Mikkel point? We know that Mikkel point means that many cyclic quadrilaterals you get, no?
Yeah.
First of all, M, A dash, B dash, C, that is cyclic, right? What are the cyclic ones? M, A dash, B dash, C. Then you have M, C, B dash, M, C, B dash, A dash, M, C, B. Okay, that I already written. Then you also have
M A dash B C.
M, A dash, B, C dash, M, A dash, B, C dash, right?
Yeah.
That is also cyclic because of the third circle. At least these two you have. You have a third one from here. B dash, C dash, M, A, right?
Yeah.
Which B dash, C dash?
Dash C M A dash.
B dash.
C M A dash.
Correct. B dash, C, M, A. Okay, that are already written, right?
Yeah.
So A dash, C dash was used up. A dash, B dash, so B dash, C dash, and A, M. That is also correct. B dash, C dash, A, M. It doesn't look very easy to see. B dash, dash, A, M, B dash. It is fine. No, this could be cyclic. Okay. See, this one. This one could be cyclic. No? So, at least first two, though, you definitely have a cyclic. Now, from there, you want to figure out some properties which will help you prove that M also is cyclic with. You also have to prove that M, A, B, C is also cyclic. No?
Yeah.
If you can prove that, that means M lies on the circle with points A, B, C, right? Circumcircle. So to prove M, A, B, C is cyclic, all you have to do is, actually what you have to prove is A dash, B dash, C dash are collinear, right?
So we are going the forward direction of that.
Actually, you can assume go in any direction. You can also assume that M, A, B, C is cyclic, no?
Okay.
Right? Because the question says lies on circumcircle if and only if, right?
Yeah.
So maybe you can start from assume that it lies on circumcircle and prove that it is collinear, right?
Yeah.
Correct. So let's write down some angles. So angle M, how do we prove collinearity? We prove maybe that this plus this is 180, no?
Yeah.
If you can prove that this plus this is 180, then we know collinear, right?
Yeah.
So angle M A dash C dash is equal to M A dash C dash will be equal to
M B dash M B C dash.
M B C dash, correct. M B C dash, correct. Angle M B C dash, but angle M B C dash is equal to Uh,
180 minus.
180 minus MBA, right?
Yes.
Like this, if you connect it here, 180 minus MBA. Okay, so let's write it MBA. Let's, okay, so we have got some sense of MA dash C dash. Let's also write MA dash B dash. Angle
That
MA dash B dash will be equal to
MB dash C.
M B
No.
dash, no, MB dash C doesn't, right? It is going to be equal to, that is also correct actually, but it is not equal to that. It is 180 minus MB dash C, no?
Yeah. Yeah.
MCB dash, right?
Yes.
This MA dash B dash is 180 minus MCB dash, right?
Yes.
This is cyclic quadrilateral.
Yes.
So you have MCB dash is equal to
MCA dash. Yeah.
MCA, no?
Yeah.
MCB dash is the same angle as MCA. 180 minus angle MCA. This is MCB dash is same. Extend B dash is A only, right? So,
Yes.
so you have two results. Now, what is the sum of these two? It is 360 minus MBA plus 360 minus MBA plus MCA. MBA plus MCA, right?
And that's 180.
And that's 180 if and only if this is cyclic.
Yes.
If
Yes.
this is cyclic, then this is 180 and then this whole angle becomes 180. So then points become collinear.
Yes.
So
And
both are interchangeable now, no? So
yes.
if
So we
points are collinear, then this is cyclic. If this is cyclic, this is collinear.
yes.
Yes.
You understand? It is obvious now. So basically to prove collinearity, write down this angle plus this angle, and that should sum up to 180 degree, only then it will be collinear. So we are just writing down the angles and making use of two of the cyclic quadrilaterals. One cyclic quadrilateral was MA dash B dash C, and one cyclic quadrilateral was MA dash B dash B C dash, right?
Yes.
So using those two, we are writing these results, and we got it in terms of the third cyclic quadrilateral, which is the triangles circumcircle, the big triangle circumcircle. So this proves that both of the statements are equivalent, and we have a result. So next what we want to do is some basic results on tangent segments. Fourth one is tangent segments. So let's see what we mean here. Fourth result is, there's a part one to it. Let W be the in circle in triangle ABC. Let D be the tangent point of W with side BC. Prove that AB plus CD is equal to AC plus BD. Very straightforward. Just draw a diagram, you'll get it.
Yes. So because the tangent lengths are equal
Uh,
from one point.
Everyone just draw a diagram. D be the tangent point of W with respect to side BC. In circle you are drawing A, B, C. This point is D. You have to prove that AB plus CD is the same as this plus this. Which makes sense because you can call this X, you can call this X, you can call this Y, you can call this Y, and you can call this Z, and you can call this Z. AB is y plus z plus CD is x. So that is whole is x plus y plus z. And this is z plus x and this is y. That is also z plus x plus y, right?
Yes.
So notice the pattern. The pattern is nice. The pattern is like this. There is a circle like this, A, B, C. This point is D. So you have this plus opposite one is equal to this plus this, right?
Yes.
AB plus CD is AC plus BD,
Yes.
right? Are you seeing the thing that is happening? Correct. This and this are equal to this and this. Okay. So this was a very straightforward thing. You know 10th standard properties are enough. Second one is, we have already discussed this, but I'll just write it because it is important to know. Let W and WA be in circle and X circle. X circle in triangle ABC. X circle is opposite to AX circle. A1, B1, C1 tangent are tangent points of W with the sides BCCA AB with sides BCCA AB. Then A2, B2, C2 are tangent points of A2, B2, C2 tangent points of WA with BCCA AB with BCCA AB. Okay. First thing to prove is AB plus BA2 is equal to AC plus CA2. And second thing to prove is BA2 is equal to CA1. That is A1M is equal to MA2, where M is midpoint of PC. These are the two things. We have already discussed this briefly as part of solving another question last week, but I want you guys to independently get it also. I will draw the figure in the next screen. For now, you guys draw your own figure. There is an in circle here, and there is an X circle here. So this is A, B, C. This is A1, this is B1, this is C1. This is A2, A2. This is C2. This is P2. This is an in circle, X circle situation, and M is the middle point of AC. M is the middle point of BC. So what you have to prove is first AB plus BA2 is equal to AC plus CA2. AB plus BA2 is AC plus CA1. No, CA. It should be CA1.
Yes. So
It should be CA1. There is a printing mistake. CA1. The second thing to prove is BA2 is equal to CA1. Equal to CA1. That is M is A1M should be equal to MA2.
So if BA2 is CA1, then AB becomes AC. So it should be CA2 only.
Hmm?
So if we substitute 2 into 1, then we'll get AB is equal to AC.
BA2 is CA1. Oh, oh yeah.
So then it's CA2 only.
Oh yeah, CA2 only. Okay. BA2 is equal to CA1, he has proved. Okay, okay, makes sense. Yeah. Okay, so this is what we have to prove
Yes.
first, and then we'll prove the rest.
So BA2 is equal to BC2
Mhm.
and CA2 is equal to CB2.
Correct. BA2 is equal to BC2 and CB2 is equal to CA2, right?
Yes. So AC2 is equal to AB2 because they are tangents from point A. So
AC2 is equal to AB2. Yes.
yeah. So we are done.
So how?
Yeah, so because AC2 is equal to AB plus
Uh,
BC2 and AB plus BC2 is AB plus B A, A2,
AB plus
B8,
AC2 is equal to AC.
AB plus BC2
AB plus BC2, correct?
and that's AB plus BA2.
AB plus BA2 and
Same.
AC2. Similarly, you can write AC plus CA2 is equal to AC plus AB2 or CB2.
Yes.
AC plus CA2 is equal to AC plus
So at AC
AB2.
plus CB2, yes. Yes.
So it becomes AB2, which is making this side equal to this, which is equal to this, right?
Yes.
Right.
Yes.
So basically what comes is ultimately what you can also prove that is AC2 is equal to AB2. This whole thing is equal to S, right?
Yes.
Semi-perimeter. So because 2 times S is equal to AC2 plus AB2, right?
Yes.
Uh,
So,
so if you do this plus this, AC2 plus AB2, it is AC plus AB plus this, which is this plus this, which is BC, right?
yes.
2S is equal to perimeter. This thing is equal to AB plus BC plus CA.
Yes.
So 2S is equal to perimeter. So this is equal to S. So if
Yes.
this whole thing is equal to S, then this part is equal to S minus this side. This side is called what? C.
Yes.
This part is S minus C. This part is S minus B, right?
Yes.
So that means uh, from here to here, BA2 is equal to S minus C and CA2 is equal to S minus B, right?
Yes.
Correct. And now in the inside the circle, for the inside circle, we also know similarly we can prove that this part is S minus B and this part is S minus B, no?
Yes.
We can prove that A1B is equal to S minus B.
Yes. Which is equal to B1 BC.
And A1B is also equal to CA2, which is S minus B, right?
Yes.
So we can prove all of these results. Mansi, you're getting, no?
Yes, sir.
So you're getting A1 and A2 are equidistant from this and this, right?
Yes.
A1 and A2 are equidistant from B and C. So then M, which was the midpoint of A1, A2, is also the midpoint of A1, A2, no? M
Yes.
was defined to be midpoint of BC.
Yes.
But now you have cut off equal sections from B and C from the outsides, right? So
Yes.
M should also be midpoint of A1, A2.
Yes.
So A1M should be equal to A2M, right? So notice this figure and all the things here. So if you have an in circle like this, and A, B, C, then the distance to the tangency point is S minus B, S minus B, S minus C, S minus C, right?
Yes.
For B vertex, it is S minus B, S minus B. if you have an X circle, from B to the tangency point is opposite vertex S minus C. See? You understand? And from C to the tangency point of X circle is
Yes.
S minus B.
Yes.
And remember that this whole tangency is equal to semi-perimeter.
Yes.
Because of this proof, right? So once you do the proofs yourself, this is not a difficult question. So it should be fairly straightforward. Then we have, okay, tangential quadrilateral. This we have also already discussed. I will just write the statement. You can, it is immediately obvious. So this is, let ABCD be a quadrilateral, such that there exists an incircle which is tangent to its sides, all sides. So you want to prove that sum of opposite sides are equal, which is obvious, right?
Yes.
Of the quadrilateral are equal. So you draw a circle and you are drawing a quadrilateral like this, right? This is
Yes.
A, B, C, D. Obviously, all sides sum will, opposite side sum will be equal, because this is equal to this, this is equal to this, this is equal to this, and this is equal to this, right? So
Yeah.
opposite sides are 1, 2, 3, 3, 4, and these sides are 1, 3, 2, 4, right?
Yes.
2, 3, 1, 4.
Yes.
Makes sense? Okay. So in a if a quadrilateral is inscribed inside, if a circle is inscribed inside a quadrilateral, and if that is possible, then that quadrilateral is such that AB plus CD is equal to AD plus BC. Sum of opposite sides have to be equal. Okay, this was the fifth thing. This I will not prove because it's very obvious. Then
So is
sixth,
the opposite also true?
opposite of it, it is a double implication, no? Because as soon as you make a circle inside it, right?
Yes. So, but if the sum of opposite sides are equal, does there exist a circle?
Then you will be able to draw a circle, no? Because why not?
So, yes.
I mean,
Does it necessarily?
you might not have a construction. A construction also is possible, because for a circle, for drawing a circle like that, you need a point which is equidistant from 4 points, no?
Yes.
A point which is equidistant from 4 sides, right?
Yeah.
So start drawing the internal angle bisectors,
Yes.
and 2 of them will intersect at one point, then third one should also pass through it, right?
Yes.
If it does not pass through it, then you will not get it, right? All 4 angle bisectors should pass through it, right?
Yes.
So you can try proving it, okay, all 4 will pass through one. Maybe take 3 of them pass through and then prove that 4th one also passes, right?
Yes.
So 3 internal angle bisectors, but
Oh,
that
so
is also
that's
not
the
necessary.
so that's necessary, so because that's the in circle of that triangle.
In circle is congruent. So in circle of this triangle is possible,
Yes.
but we don't want to draw in circle really, no.
So
In circle
three
will
of
be,
them will intersect, then we have to show third one, fourth one also intersects.
no, it is not possible, no, because see, in circle if I draw, no,
Yeah.
then so it will not touch those two, no.
Okay.
You understand?
Yes.
This is not the same point as in circle of this, right?
Yes.
Yes.
So slightly different it is, no?
Yeah.
Yes.
So you have to assume 2 of them will definitely intersect. 2 bisectors will definitely intersect, and
Yeah.
the other two angles bisector, you have to prove that they also pass through this. only then will you get that this point is equidistant from this and this, right?
Yeah.
And this, so it might not be trivial to prove the other side, but it might not be very obvious, but maybe those opposite sides are equal property will help you prove it. So I'm not sure, I've not tried it, but you guys can try it, the opposite side. Okay.
Yes.
Okay, sixth one is okay, this is the important result. Let M be the midpoint of side BC, side BC in triangle ABC. Let E dash be the point on the circle, point on circumcircle, circumcircle, such that A dash is a diameter, let H be orthocenter of triangle ABC. 1. Prove that H M A dash are collinear. Okay. Second thing, AH is equal to 2OM, where O is circumcenter. And then we come to the Euler line. Third result from here is let HTO be orthocenter, centroid and circumcenter, Prove that HTO are collinear, and HT equal to 2 times TO. So these three results we want to prove. Like, the reason we have started with this is because these are the preliminary steps that help you prove this.
Yes.
Start
So,
from here. Yeah.
yes. The Euler line is proved using similarity, right? Because
The final result can be proved in multiple ways. Here I want you to start off from proving this. So let's try by proving first this, and then you go to slowly second and third.
yes.
You can also prove that Euler, the alternate proofs are there. The similarity proof that you're saying is possible. I will just draw a figure. Let triangle ABC be like this. ABC is a triangle, and we are given M is midpoint of BC. A, B, C. M is midpoint of BC. And A dash is the point on the circumcircle which is opposite to this, right? So circumcircle could be like this. 1 second. A dash is the point on the circumcircle which is opposite, such that A dash is a diameter. So if circumcenter is somewhere here, O, this distance O, AO, okay, my point O is not correct. O will be directly above M.
Yes.
O will be somewhere here. So A O A dash. A dash is here. This is O. Let H be the orthocenter. So I'll draw an altitude here and one altitude like this. So H is the orthocenter. H. Finally, prove that H M A dash are collinear. So apparently these 3 points have to be collinear. Right now it just misses a little bit, but fine. H M A dash are collinear. So let's mark this point as D. Extend this to meet it here.
So those two are 90 degrees, like if you join OM.
Which ones? This one. Yeah,
OM, so they are parallel.
correct. They are parallel. Join these also. Everything, join everything. We want to prove that this is collinear. Everyone can see that OM is and AX are parallel. X, wait, X. Let's say this point is X. Okay. A dash M and AD intersection point is not known to be orthocenter. It could be any point, right?
Yes.
We want to prove that they are collinear. So let's say X is the point where this A dash M meets AD, right?
Yes.
I'll just rub this a little bit and draw it slightly better. So A dash M okay. A dash M meets AD at some point X. We don't know whether X is the orthocenter or whether it is some other point. So orthocenter could be any point anywhere on this altitude, right?
Yes.
Orthocenter can be anywhere on this altitude. We don't know whether X is the altitude or something else is the altitude. So, okay, we want to prove that X is same as H.
Yes.
Then this straight line is cutting it at orthocenter. Then we are done that HM A dash is collinear, right?
Yes.
So what do we know? We know OM and AX are parallel, right?
Yes. And AO is equal to OA dash.
Which one? Which one? AO is equal to OA dash. We know, yes. AO is equal to OA dash. So O is midpoint of A dash is bisected at O, right?
Yes. And also, so they can be similar because they have one angle and.
So one thing that you can see is OM is parallel to AX and O passes through midpoint of A dash. So this is midpoint theorem, no?
Yes.
A line parallel to the base passing through one midpoint will pass through the other midpoint.
Yes.
So we know that M is midpoint of X A dash. So we know that XM is equal to M A dash. Correct?
Yes.
Okay. So, okay. So we have some nice similar triangle properties here, right? But maybe right now it is not immediately useful. So let's go about it as little differently.
So for the second one, it comes from this similarity.
Second one will come from this, I think. AH is equal to 2. Okay, so right now let's not worry about H. First prove that X is equal to H. Let's do that, right?
Yes.
After that, we'll be able to prove the rest. So AD line, that's why let's extend AD line to meet the circumcircle at E. So AE A dash, this is 90, no? Because these two lines are parallel, right?
Yes.
These two lines are parallel. So 90-degree this is. So then now, no, actually the reason that this is 90 is because A dash is a diameter.
Yes. So they are not parallel.
They are
Now,
not parallel. We
now,
don't know that earlier.
yes.
We don't know that this will be 90 earlier. We know it because A dash is a diameter. No?
Yes.
Angle in a semicircle. Now you will say that it is parallel.
Yes. So now BC is parallel to EA dash.
Correct. You know that BC is parallel to EA dash. EA dash because 90 and 90, right?
Yes.
Corresponding angles. So EA dash is therefore parallel to DM, right? Okay. And we also EA dash is parallel to DM, and we know that M is the midpoint of BC, no? Oh,
Yes.
we don't know M is
Of XA dash.
X A dash. We got it here, right?
Yes.
So
So
EA is parallel to DM, and M is midpoint of XA dash.
yes.
So that means D is midpoint of
XD.
XE.
And
Again,
that,
midpoint theorem.
yes.
Everyone is following why midpoint theorem. These
Yes,
two
sir.
lines are parallel, and one is the midpoint of this. So this is equal to this, and earlier we have proved what?
So yes. So the reflection across BC lies on the circumcircle.
Correct. We have proved earlier that orthocenter's reflection across the base of the side lies on the circumcircle. So now suddenly we are getting this is equal to this. That means this point's reflection lies on circumcircle. So this point must be orthocenter.
Yes.
Correct. Mansi?
Yes, sir.
Yeah. So X must be orthocenter because its reflection is lying on circumcenter. We have proved that this distance is equal to this distance. So now we have X is orthocenter. So we have proved that HMA dash are collinear. Okay.
Yes.
Now we have to prove that AH, A to H, this is H now. Let's label it as H. AH is equal to 2 times OM, which is obvious by midpoint theorem now,
Yes.
right? Because we have proved this is midpoint and we already know this is midpoint, right?
Yes.
So AH must be double of OM, right?
Yes.
Okay. So let's go to the third one now. Third one, we have to prove that first part we have to prove HTO are collinear. T is the centroid of the triangle, right?
Yes.
T is the centroid of the triangle. So HTO are collinear. Okay. So okay. So first of all, T must lie on the line joining H and O. No, so let's join H and O. Okay. We have to prove what? That centroid lies on this line, right?
Yes. So we can join AM because
Correct.
M is the yes.
Correct. Join AM because AM is a median, no?
Yes.
We were given earlier M is midpoint of side BC, right?
Yes.
So AM is a median and H and O we have joined, and we are trying to prove that centroid lies on this HO line, right? So centroid will anyway lie on the median only. So let's call this median, this point of intersection of AM with HO as T dash. Our job is to prove T dash is equal to T, right?
Yes.
Correct. So, okay. So I will just rub off a little bit of the stuff. So fine, just work with this one. AHT dash and MOT dash. These two triangles, this triangle and this triangle,
Yes. So they are similar.
they are
So
similar.
the lines are parallel and
Lines are parallel. These
yes.
two lines are parallel, so many angles are matching. No, this angle
Two angles.
and
So
vertically opposite.
so vertically opposite is not yet done. Oh yeah, yeah.
Vertically opposite is also done. HO.
Yes.
Vertically opposite and parallel lines. That's it, right?
Yes.
So these two triangles are similar. So we have a result. I'll just write it, ratio of the sides result. So
Yes.
we'll write it here.
So it will be 2:1, and then that's why it's okay.
2:1 you got?
Yes. So because AX upon OM is
Correct, correct.
yes.
This upon this was 2:1 from this, right?
Yes, sir.
Correct. So similarly, this side and this side must also be divided in 2:1 ratio, no, here. So
Yes.
ratio comes as AH by MO is equal to AT dash by MT dash is equal to HT dash by OT dash, right?
Yes.
This is the similarity ratio, but AH is equal to 2 OM, right? So this is 2 by 1 is equal to AT dash by MT dash, right? So T dash bisects A and M in the ratio 2:1. In ratio 2:1, but
Yes.
AM is a median. So point which bisects in the ratio 2:1, a median is a centroid. So T dash is the centroid.
Yes.
And we also get from here HT is equal to 2TO
Yes.
because of this third relation. T dash is now T, no? T dash we have proved it is equal to T, which is the centroid. So HT is equal to 2TO comes.
Yes.
So basically we have proved all the Euler line properties, right?
Yes.
We have proved that HTO are collinear and HT is equal to 2T dash. The way we proved it is by proving HMA dash is collinear and AH is equal to 2OM,
Yes.
right? So we had a triangle here and A, B, C. We had an altitude. We had a midpoint here M, and what we did was circumcenter was somewhere here. We took the point here. This point was A dash, point on the circumcircle. Okay, and we proved that H orthocenter A dash M A and orthocenter are collinear. Correct?
Yes.
First, we proved A dash H M are collinear by taking some arbitrary point X here and proving that this point X was just orthocenter,
Yes.
right? And once we got that AH is equal to 2OM. AH
Yes.
is equal to 2OM, and then we joined this and joined this, and we
Yes.
proved that T dash is equal to T, centroid. So we have proved the Euler line result that if you join orthocenter with the centroid, orthocenter with circumcenter, then centroid lies in 2:1 ratio. Correct?
Yes.
Okay. Next, next we'll prove. I think this was number 6, no? Now we are on number 7, right?
Yes.
Okay. Let A1, B1, C1 be the midpoints of sides BC, CA, AB in triangle ABC. Let D be the foot of the altitude of the perpendicular from A to BC. Prove that D lies on circumcircle of triangle A1, B1, C1. Prove that D lies on circumcircle of triangle A1, B1, C1. A1, B1, C1 is like the medial triangle, no?
Yes. Sir.
It is
So,
like the
so I think we already did this one.
You already did it, okay?
I don't remember. I think.
It looks familiar. Yeah.
Yeah.
A, B, C. Midpoint here, A1. Midpoint here, B1. Midpoint here. There's some slight problem with the figure. Wait. Uh, C1. So, okay. So, circumcircle of this triangle. Something like this it will be.
Yeah.
We have to prove that this is an altitude.
Yeah.
Prove that D is the foot of the altitude from A to BC. Then D lies on circumcircle. Okay. Try this. So basically, what do you have to prove? That A, B, C, D is a cyclic quadrilateral. No, A1, B1, C1.
Yeah.
To prove that D lies on circumcircle, we have to prove that this quadrilateral is cyclic.
Yeah.
Okay. So two opposite angles, if you can sum to 180. So let's take C1, B1, A1, angle C1, B1, A1 plus angle, what we need is C1, D, A1, right?
Yeah.
If we can prove that these two angles are summing to 180, then we are done, right? Okay. So C1, B1, A1. So C1, B1, A1, can we figure out the angle? Wait. We know that this is a B1, C1 is parallel to BC, no?
Yeah.
And similarly, A1, B1 is parallel to AB, right?
Yeah.
So C1, B1, A1, C1, B1, A1 should be equal to A1, C1, B1. This is theta, then this should be theta, no?
Yeah.
Right? Parallel lines, and this is theta, then this should be theta.
Yeah.
Correct?
Yes, sir.
So this angle is equal to B, no?
Yeah.
And what about C1D A1? C1D A1. We have to prove that it is 180 minus B. So let's find this angle instead. Let's find this angle. So
That should be B.
why?
No, then we would have to.
Ha. So oh, okay. So now look at the triangle like this: ADB, right? DAB, right?
Yes.
And this is the point. C1 is the midpoint, no?
Of the hypotenuse. Yes.
C1 is the midpoint of the hypotenuse. So C1 is circumcenter of this triangle, no?
Yes.
Right angle triangle it is, right?
Yes.
So this distance must be equal to this distance, must be equal to this distance.
Yes. So that's
This
B.
angle is equal to this angle.
Yes.
So C1DB is equal to B only. So this angle must be 180 minus B,
Yes.
correct?
Yes, sir.
So this angle is 180 minus b, and this angle is b. So it is adding up to 180. So D, A1, B1, and C1 is a cyclic quadrilateral. So D lies on circumcircle
A1, B1, C.
of A1, B1, C1. So similarly, now you can say some other things also, that alt. This was what? What was special about D? D was the foot of the perpendicular from A to this, right? Similarly, foot of the perpendicular from B to this should also lie on the circumcircle A1, B1, C1.
Yes.
There is nothing special about one altitude. No, you can draw another altitude and another altitude, right? So all three foots of the perpendicular, feet of the altitudes lie on circumcircle A1, B1, C1, right? Correct. Now the next thing that we want to prove is a similar idea. Again, A1, B1, C1 are midpoints of BC, CA, AB. Let H be, H is orthocenter. H is orthocenter of triangle ABC.
It will be circumcenter of.
Let X be the midpoint of AH. Prove that X lies on circumcircle of triangle A1, E1, C1. Again, same thing, same triangle actually. This is H, this is A, this is B, this is C, this is A1, this is B1, this is C1, A1, B1, C1 triangle, and you have to prove that circumcircle of this triangle passes through this point, right? Circumcircle of this triangle is somewhat like this, and this point is X, midpoint of AH.
Yes.
So basically, we are trying to derive the 9-point circle.
Yes. Yes.
Everybody has realized, no?
Yes.
Yes, sir.
Right. So I will just make a different drawing. So not a nice figure.
So there'll be 6 points after this. If
We have
get,
already gotten 6 points, no?
yeah, if we get this. Yes.
We got 6 points. We are doing the last 3 points.
Yes.
Previous proof gave us the 3 extra points, no?
Yes. So we have proved them in 2 separate points.
2 separate parts we can prove the 9-point circle thing. So this is the triangle. This is orthocenter A, B, C. I want a triangle here, triangle here, triangle here. This is my medial triangle. So that also tells us one nice thing, that 9-point circle is circumcircle of medial triangle, no?
Yes.
Circumcircle of medial triangle. That is A1, B1, C1. And which immediately implies that radius of 9-point circle will be R by 2, right?
Yes.
If the circumcircle of the original triangle radius was R, then half this medial triangle is just the original triangle by 2, right?
Yes.
A1, B1, C1. I want to prove that its circumcircle passes through midpoints of the AH, BH, CH. Yeah, I will not draw the circumcircle because it is ruining everything. So assume that the circumcircle should pass through some point which is midpoint. This is X. We have to prove that. So
So again cyclic.
so again, proving it is basically trying to prove that x c1 b1 a1 is cyclic.
Yes.
So
X C1 A1 B1. Yes.
x c1 a1 b1 x c1 a1 b1, correct. So that is cyclic quadrilateral. So basically prove that two angles are summing up to 180, right? So therefore try to prove angle x c1 a1 plus angle x c1 a1 and x b1 a1, right?
Yes.
If you can prove that these two angles add up to 180 degree, we are done, right? So let's try to figure out our individual angles. X b1 a1, x b1 a1, or x c1 a1. So what will be the angle we have to figure? Okay, so now what is given? X is the midpoint of AH, no?
Yes.
X is the midpoint of AH. So
And
C1 is the midpoint of
AB.
AB. So in triangle ABH, right?
Yes.
In triangle ABH, if you look, C1X is the joining two midpoints, no?
Yes.
Everyone can see C1X is the mid segment of midline of triangle ABH, right? So you have C1X is parallel to BH, right? Correct.
Yes.
So since BH is perpendicular to AC, C1X is perpendicular to AC, right? Correct.
Yes.
Parallel, no? This became parallel to this. So this is 90, then this is 90. Correct. So this angle becomes 90 minus A, right? This angle.
Yes.
AC1 this point, right? So, okay, this angle became 90 minus this. And similarly, we have C1A1. C1A1 is parallel to C1A1 is parallel to CA, right? Correct.
So we already know.
C1A1 is parallel to CA. We already knew that, right?
Yes.
So then we have C1X. C1X is perpendicular to, oh wait, nice. C1X is coming perpendicular to AC, no? C1A1. See?
Yes.
Are you getting it? See, C1A1 is parallel to AC,
Yes.
and C1X we just saw is perpendicular to AC, no?
Yes.
So C1X is perpendicular to C1A1. So this angle is 90,
Yes.
right?
Yes.
And similarly, X B1 X B1 A1. We can also prove this angle is 90 because
It's parallel to AB.
this line is X B1 will be parallel to
C1 A1. No.
us.
Not
Not C1 A1. Parallel to CH.
Yes.
X B1 will be parallel to CH because midpoint, right?
Yes.
And CH is CH parallel to CH. So what will happen is CH is perpendicular to AB.
Yes.
So X B1 is perpendicular to AB.
Yes.
X B1 is perpendicular to AB. And now what we can say is A1 B1 is parallel to AB. No? So X B1 is perpendicular to A1 B1 because A1 B1 is parallel. No, these are parallel.
Yes.
So this angle is also 90. Adhish, are you getting?
Yes.
So then it has become cyclic, no?
Yes. So, yes.
It has become cyclic because opposite angles are summing to 180. So we have proved that the midpoints of the line joining orthocenter to the vertices also lies on that circle, same circle. So
Yes.
we have one circle passing through 9 points. What are the 9 points? We have, this is orthocenter, suppose. This is orthocenter H. This is midpoint, midpoint, midpoint. And we, in the previous question, what did we prove?
The midpoints of sides and
Feet of the altitudes, right?
yes, sir.
We proved that 3 feet of the altitude are D, E, F. We proved that the circumcircle of these 3 triangles, right? This triangle.
Yes.
Circumcircle of this triangle passes through D. Now we proved that it also passes through midpoint of AH.
Yes, sir.
And it also passes through, so midpoint of BH also it should pass through, and midpoint of CH also it should pass through somewhere,
Yes.
right? So now we are getting 1, 2, 3, 4, 5, 6, 7, 8, and
9.
one more 9, right?
Yes.
So this 9-point circle we are getting. This is a 9-point circle, and actually now you are getting even more stuff. You are
Because-
getting
Yes.
that 9-point circle is the circumcircle of triangle
Yes.
A1, B1, C1. So radius of that 9-point circle is r by 2, right? Correct.
Yes.
Okay. Radius is r by 2 we got, and center of the 9-point circle will be the midpoint of OH. Center of 9-point circle and circle will be the midpoint of O2H. O2H. When you join the orthocenter, and this you can try and prove yourself, because I'm sure you can prove it. So it just draw the medial triangle and try to find the circumcircle of median triangle, right? That
Yes.
point will be
Center of 9 points.
so O2H, OH is the for the big triangle ABC, right?
Yes.
So OH, when you join big triangle, that midpoint you have ONGC. This is 1, this is 1, this is 2, this is 1. So you can actually prove it by similar triangles. Once you draw a nice figure, no, the earlier thing that we did, net, that OH is equal to 2AM or something we got, right?
Yes. So Euler line.
AH is equal to 2OM, the Euler line proof. From there, from a similar triangle, there you can get it.
Yes.
Something like that will happen. Or maybe include the 9-point center also, only then you will get it, right? So
Yes.
somewhere 9-point center you have to find and try to prove it. So just that will be homework. Let's do something new now.
So it's there in SL only.
This 9-point circle stuff is there in SL. So so next one is let ABCD be a convex quadrilateral. Let MNPQ be midpoints of sides AB, BC, CD, and DA. Prove that MNPQ is a parallelogram. That is a very easy thing.
Yes. So from midpoint.
As soon as you draw the ABCD and join the midpoints, this is one midpoint, this is one midpoint, this is one midpoint, this is one midpoint, right?
Yes.
And this is M, N, P, Q. So just draw one diagonal.
Yes. So it's parallel to the diagonal.
Uh,
P
it,
is parallel to.
Mn will be equal to half of BD. NP will be equal to half of BD, and MQ will be equal to half of
I've wrote this.
what? Okay, you will be able to prove this. This is equal to equal and parallel, right? They will be parallel to the same thing, and it will be equal to half of this. Correct?
Yes.
Yes.
So MNPQ will be a parallelogram. Now we are not done yet. This is just the beginning. So next next result here only we want to see is let ABCD be a convex quadrilateral, be a convex quadrilateral with perpendicular diagonals, perpendicular diagonals, perpendicular diagonals. So
It will be
now,
rectangle.
so now let M and PQ, let M and PQ be midpoints of the sides. Same thing, midpoints of the sides. Midpoints of the sides. Let M1, N1, P1, Q1 be feet of perpendicular from M and PQ to the opposite sides of the quadrilateral, to the opposite sides of the quadrilateral. Now you have to prove that there is an 8-point circle. 8-point circle, that is basically prove that M, N, P, Q, M1, N1, P1, Q1 all lie on one circle. This is 8-point circle. So what is happening is ABCD is a quadrilateral, not like this. The diagonals are perpendicular, so slightly different figure. M and PQ are midpoints of the sides. From each midpoint, you are drawing a perpendicular to the opposite side. So those points are M1, N1, P1, Q1, right?
Yes.
Now, so now think about it. What will be MNPQ in this case when
So
perpendicular diagonals?
a rectangle.
Yeah, correct. It will be a rectangle because
90 degrees.
basically they are parallel and diagonals are perpendicular, so this angle start becoming 90, no? Because
Yes.
this is 90, right?
Yes.
Everyone agrees, no? This is 90, so this becomes 90 and this becomes 90. So MNPQ is a rectangle in this case. So, okay, MNPQ is a rectangle. Now from that rectangle, vertices of that rectangle, you are drawing perpendiculars on the opposite sides. Okay. So yeah, so it is not very hard. I'll just draw a figure on the next page. Try to think about it yourself once. This much everyone has understood. This is a rectangle. M and PQ is a rectangle. Now you have to drop some perpendiculars. So from here, I want to drop a perpendicular here, Q1. From here, I want to drop a perpendicular P1 and so on. P1, Q1 and all. You have to prove that all of them lie on the same circle. Here there will be a, from N, I will drop a N to opposite sides. So here, so this is N1, N1, Q1, P1, N1 and one more, M1. M to opposite side. This is your M1. M1. You have to prove that these 8 points lie on one circle. Okay. So, what can you say about quadrilateral MNPQ? Besides being a rectangle, what does it mean also? It means that since angles are 90,
PM is the diameter of the
correct,
sphere.
correct. PM is the diameter. So if you draw a circle passing through M and PQ, right? If you draw a circle passing through M and PQ, PM and NQ will be diameters. Diameters. Now, MM1, is it perpendicular to CD? It is given from the definition, right? Correct.
Yes.
MM1 is perpendicular to CD is given, right? So now what it means is that angle MM1P is equal to 90 degree, correct?
Yes, sir.
MM1P is 90 degree. So PM was the diameter, no? So M1 is another point on that semicircle, no?
Yes.
Point on semicircle, right? Because suppose you have a circle and you have PM as diameter, right?
Yes.
PM as diameter, then, and if you found another point somewhere where angle M1, MM1P
Is 90.
is 90, so M1 must lie on that same circle, no? Which passes through P and M, right?
Yes.
Yes, sir.
And on that same circle, P and M, what also lies? N and Q also lies.
Yes, sir.
And this is a cyclic quadrilateral. This is cyclic. So M and PQ is cyclic quadrilateral, and for N also you will find a similar point Q1,
Yes.
and for M also you'll find P1, and you basically get one extra points, no? Because
Yes.
by definition you have put 4 more points which are perpendicular to the sides, right?
Yes.
So you have one circle on which all M, N, P, Q, M1, N1, P1 and Q1, they lie, right?
Yes.
These are 8 points on one circle. This is an 8-point circle, which is what actually? It is the circumcircle of medial circle, no?
Yes.
Circumcircle of medial quadrilateral, right?
Yes. Yes.
So basically, you had a ABCD quadrilateral. You took all the midpoints and you draw the circumcircle, the circle passing through each of the midpoints, right?
Yes.
And it cuts 2 times basically, right? It cuts the side 2 times. One point, one side is at the foot of the perpendicular from Q to this. Those points are also lying on that circle basically, right? So just like we had in a triangle, we drew a circumcircle for this triangle, and we drew a circumcircle for this, and we found 9 points on it, right?
Yes.
In a quadrilateral, we drew a circumcircle for this, and we found 8 points on it, right?
Yes.
You understand? Okay. So next one is a very old result. It is called Brahmagupta's formula.
Yes.
You might have seen it.
Yes. So the cyclic.
So Let ABCD be cyclic with perpendicular bisectors, cyclic quadrilateral with perpendicular bisectors or perpendicular diagonals that intersect at S. Let M be the midpoint of side AB. Prove that MS is perpendicular to CD. This is not Brahmagupta's formula, this is Brahmagupta's theorem.
Okay.
There is a Brahmagupta's formula for area of a quadrilateral.
Oh, yes.
That is what is more popular.
So, yes.
Okay. So this is a cyclic quadrilateral with perpendicular diagonals which intersect at S. M be the midpoint of side AB. So let's draw. I want a cyclic quadrilateral, so perpendicular diagonals I'll first draw. This is a quadrilateral. This A, D, C, B. This is my cyclic quadrilateral, diagonals are perpendicular. This point is S. What I want to prove is midpoint of AB is M. Okay. MS is perpendicular to CD. This is what I want to prove. Let's make it intersect at CD at E. So I want to prove that angle SEC is equal to 90 degree. Prove. So think about it, try. Any ideas? What is happening? Hint is look at right angle triangle ASB. We know that
Yes. So,
M is the midpoint of hypotenuse, no?
yes.
So MB is equal to MS because
Yes.
hypotenuse is the circumcenter of this right angle triangle, right?
Yes.
MB is equal to MS is coming. So angle MBS is equal to angle MSB.
Yes.
MBS is MSB, right? So this
Yes, sir.
and this are equal.
And that's equal to ACD.
Which one? ACD is equal to MBS, right?
Yes.
So and equal to SCE, then S is equal to
S.
MSB, right?
MSB is equal to SCE.
SCE. Yeah, wait. So angle SCE is equal to angle ACD is equal to angle ABD is equal to angle MBS is equal to angle MSB. No, this is the series, right?
Yes.
You get SCE is equal to MSB. So SCE is this angle is equal to this angle. Now, okay. Now ESC plus SCE is equal to angle ESCE plus angle ESC. ESC is equal to ASM, no?
Yes. So alternate. In vertically opposite.
Vertically opposite this and this, right? And ASM plus SCE is MSB, no? SCE is MSB.
Yes, sir.
MSB plus ASM is equal to 90 degree, no? By given in the question, right? Perpendicular diagonals. ASM plus MSB it has come, no?
Yes.
See, this one is MSB and ESC is equal to ASM. So
Yes. So that's what's right.
so this plus this is 90. So this is 90. So you have proved that MS is perpendicular to CD because angle SEC is coming as 90.
Yes.
So sometimes these, whenever you have these right angle triangles, no, and there is a midpoint, then circumcenter. This is important to notice, right? This part is in previous questions also we have used it once or twice, right?
Yes.
So this is Brahmagupta's theorem that cyclic quadrilateral with perpendicular diagonals, if you join that point of intersection or point of the diagonals with a midpoint of one of the sides, that line is perpendicular to the other opposite side. Okay. Now, why are we doing this? Because now we'll come to one important result where we will understand a little more about that 8-point circle. So 8-point circle that we just drew earlier. See, notice that that was also for a cyclic quadrilateral with perpendicular diagonals. ABCD be a cyclic quadrilateral. That 8-point circle result was also having perpendicular diagonals, no?
Yes. Sir.
Then only we got MNPQ is a rectangle, right?
Yes.
Only then we can do that. So let's say ABCD is a cyclic quadrilateral with perpendicular diagonals that intersect at S. That intersect at S. So let O be the center of circle circumscribing ABCD. Prove that 8-point circle of ABCD, 8-point circle of ABCD is centered at the midpoint of midpoint of OS. So let's try to think about what is happening. So we have a cyclic quadrilateral with perpendicular diagonals. Okay, the figure is very small. But let's first draw a circle. This is a circle, and let's draw a quadrilateral with perpendicular diagonal, cyclic quadrilateral. So we have something like this. This is one. This is one. This is a cyclic quadrilateral A, B, C, D. Okay. They intersect at S. O is the center of this circle, this circumcircle, right? O is the circumcircle of this cyclic quadrilateral. So O is the center of that circle. Now, we have to prove that 8-point circle is midpoint of OS.
Yes. So
Center of OS, 8-point circle is midpoint of OS. Okay, so 8-point circle, how did we draw? Let's try to recall. So what do? You have a cyclic quadrilateral like this. You take midpoints, right? And from the midpoints, you joined the midpoints. You had some midpoints of the sides, and from each midpoint you dropped perpendiculars also, right?
yes.
There's a point here. From this midpoint perpendicular here will be some point here. From this midpoint perpendicular here will be some point here, and from this midpoint perpendicular here will be some point here. These 8 points lie on a circle, right? That is what we did earlier, right?
Yes.
And M and PQ, this is M, this is N, this is P, this is Q. This is a rectangle. M and PQ is a rectangle, right?
Yes.
I mean, it is not rectangle in my figure, but my figure is wrong. So that's fine. M and PQ is the midpoints of the sides. So M and PQ, midpoints of sides. And we have M1, N1, P1, Q1 are feet of the perpendiculars. M1, N1, P1, Q1. Feet of perpendiculars from midpoints to the opposite sides. Now, we saw earlier when we did the derivation that MP was a diameter, no? Diameter of the 8-point circle, remember?
Yes. Because P1 is 90.
Because that angle was 90, no?
Yes.
MP was diameter because the diagonals were perpendicular, no?
And because it was a rectangle.
Because it was a rectangle, yeah. So M and PQ was lying on that circle, and M and PQ was a rectangle. So MP was a diameter. And that is how we proved that the other point is also making 90 degree, right?
Yes.
That is how we proved that it was lying on the circle. So we need to prove now, that 8-point circle center will be midpoint of MP, no?
Yes. So that should be on S.
So midpoint of OS and midpoint of MP should coincide, right?
Yes.
So my figure is totally wrong. Something is really wrong in my figure. But MP, I think I've labeled it wrongly or something. So we need to prove that midpoint of MP is midpoint of OS, right?
Yes.
So to prove something like this, what do we need to prove? Midpoint of MP is midpoint of OS? Then MP OS is a parallelogram, no?
Yes.
Then only midpoints will bisect, no?
Yes.
Not MP OS, MOSP.
MP, MO,
MOS.
MOPS.
If you have a parallelogram like this, MOS, oh wait,
MOPS.
MOPS, MOPS, then only you will get midpoint of MP and OS should bisect each other, right?
Yes.
So let's try to prove that MOPS is a parallelogram. So let's think about it. M is midpoint of chord AB. M is midpoint of chord AB. Okay, that is why it was wrong. M is here. So one second. This was M. M is midpoint of chord A. Midpoint of chord AB. O is center of ABCD circle. So OM is perpendicular to AB. That is obvious. OM is perpendicular to AB because O was the center of the circle,
Yes.
center of circumcircle, no?
So OM is perpendicular to.
And
Yes.
M is midpoint of AB, no? This is chord being bisected by a circle,
Yes.
right? Center from center point, right? So basically, if you have a circle and if you have any chord and if you have O, if there is a midpoint of that chord, then this line is perpendicular, right?
Yes.
So M was midpoint of chord AB, so OM will be perpendicular. OM is perpendicular to AB. Now, now we know that M to M1, M to M1, M1 is this point. M to M1 passes through S from the previous thing. Just before now, what had we proven? That MS is perpendicular to CD, no? Previous
Yes.
example.
Yes.
We also had in the previous example also we got the same thing. ABCD is a cyclic quadrilateral with perpendicular diagonals that intersect at S, right?
Yes.
So if you took midpoint of one of the sides and passed it through the S point, then that is perpendicular to the opposite side, we have proved, no?
Yes.
And we in the previous example we had shown that M to M1 was perpendicular, no? We had dropped perpendiculars from M to the opposite side, right?
Yes.
So combining those two previous examples, we should have MS is perpendicular to CD, right? And MM1 is perpendicular to CD. So basically we have MM1 line passes through S, no? MM1 passes through S.
Yes.
Mansi, are you understanding? Mansi?
Yes, sir.
So MM1, NN1, what we have is all these lines MM1, NN1, PP1, QQ1 are each passing through S. They pass through S. Because they by definition MM1 is perpendicular to the opposite side, right?
Yes.
So they must pass through S, and if they pass through S, so PS, for example, is same as PS. So PP1, for example, is perpendicular to AB. PP1 is, my labeling is wrong. My PP1 or any MM1 is perpendicular to opposite side.
Yes.
So okay, 1 second, let me think. PP1. We have to draw a different figure. I think is not very clear for
So
me.
because PS will be
Ah,
perpendicular to BC and OM will also be perpendicular. So they're
ah,
parallel.
exactly. We have to prove OM is parallel to PS.
So
So
both are 90. So that.
uh, So I'll just draw a nicer figure so that it is a little clearer. This is A, B, C, D, and this is B, A, this is C, this is D, and this is my S point, and this is midpoint M. This is, I am saying that MS, this is perpendicular, this is M1, and P is the midpoint of this side. P is the midpoint of this side, P. So P, and this is my O. OM1, O is somewhere here. OM1 is perpendicular. OM1 is perpendicular. And OS is joined. OS is joined. Now, what we have so far,
So, and we know that PS is also perpendicular.
PS is perpendicular to, PS is perpendicular here.
So they are parallel.
PS is perpendicular to AB. And OM is perpendicular to this, right?
Yes.
So clearly PS is parallel to OM, right?
Yes.
MOPS is the quadrilateral that I wanted to prove was the parallelogram. We wanted to prove that MOPS is a parallelogram.
Yes. So
And
we
you,
also got one.
and now we have clearly that PS is parallel to OM,
Yes.
and we also have MS is parallel to OP because this is also perpendicular, no?
Yes.
O to P is perpendicular to CD, and MM1 is perpendicular to CD, right? So
Yes.
therefore we have MS is parallel to OP. So we have opposite sides are parallel. So this is MOPS is a parallelogram, is parallelogram. Therefore, the midpoint of this one, midpoint of MP is therefore the
Midpoint of OS,
OS. Midpoint of MP is midpoint of OS,
which is the center.
is midpoint of OS. And how do we know that midpoint of MP is the center? Because MPNQ was the quadrilateral, right?
Yes.
MPNQ was the rectangle, no?
Yes.
So somewhere here, these are two more points, right?
Yes.
This was the rectangle type thing where MP was a diameter, no?
Yes.
MP is a diameter. We had proved that earlier. So midpoint of MP is center of 8-point circle. Center of 8-point circle, which is also midpoint of OS. So if you draw a proper figure, then it is clear. So what I want you to understand is last three examples, like from the 8-point circle, the beginning, right?
Yes.
From there, then second one was Brahmagupta's theorem, that one, and combining it with this one. We know that center of 8-point circle is the midpoint of OS. But what is O? O is the center of ABCD, right? Center of ABCD circle, right?
Yes.
And S is the point of intersection of perpendicular diagonals, right?
Yes.
Point of intersection of perpendicular diagonals. So the center of that 8-point circle is the midpoint of OS. Midpoint of OS is center. Also, that is center of MP, which is the point joining two midpoints, right?
Yes.
Makes sense.
Yes.
Okay. Okay. So with this, that is all that I wanted to discuss in terms of theory. I want to now go back to some questions from the previous assignments. Okay. So let's discuss one question first, and then we'll move on to some actual questions. One question I want to discuss is, let ABC be a triangle, acute angle triangle, acute angle triangle, and let D be the foot of perpendicular from A on BC. Let H be a point on AD. Prove that H is orthocenter. H is orthocenter of ABC if and only if DB into DC is equal to AD into HD. I think I have shown this before, but I want to revise it once more. Maybe I have shown this before, but this is an important result that I want to discuss. A, B, C. This is the foot of the altitude D. This is some arbitrary point H. We have to prove that H is orthocenter of triangle ABC if and only if DB into DC, this into this, is equal to AD into HD, this into this. Everyone understands the question?
Yes.
Okay. You can use some properties that you already know.
So from the right point of
Extend this altitude, okay?
Yes.
And make it meet at A dash, right? Now, this is circumcircle, right?
Yes.
So if you write power of point D, right? With respect to the circumcircle, right?
Yes.
Power of
Yes.
D. What is that? DB into DC.
Yes.
That is also equal to AD into DA dash.
Yes.
Now, if DA dash is equal to DH, right?
Yes.
Then the AD into HD you will get,
Yes.
and then it will be reflection of orthocenter is lying on circumcircle, no?
Yes.
You understand?
Yes.
If H is orthocenter, then HD is equal to DA dash, right?
Yes.
And you get the result. And if you have the result, then
Then you get HD is the
then you get HD is equal to DA dash. So this point must be orthocenter, right?
Yes.
Everyone is understanding? Because this is coming from orthocenter reflection on the side.
Is on the line on
Reflection on side lies on circumcircle. So, but this is not just arbitrarily I have not given this, because this is a nice result which can help you decide if some point is an orthocenter or not, right? So if some point H is an orthocenter of triangle, you can use this result. You can say, if you have to check whether the point is orthocenter, then let's say H is a point on the altitude, HD AD, right? HD into AD should be equal to BD into DC. Okay, so know this condition. This is a nice condition using power of a point, right? So H to that side and vertex to that side, the product should be equal to how the side is divided, right? BD into CD.
Yes. Sir.
So that is enough to tell you that H is orthocenter or not. If these two are not equal, H is not orthocenter, right?
Yes.
So someone can give you a question where they specify 2-3 distances, right? They say there is an altitude, there is a point here. This distance is equal to 5. This distance is 3. This distance is 12, right?
Yeah.
Right. They'll say that X is orthocenter. Then what is AX? Right?
Yes.
So what you can say is XD into AD should be equal to BD into CD.
Yes.
So XD into AD should be equal to 3 into 4. So it is equal to 12. And XD is 5 given. So AD is coming as 12 by 5.
Yes.
AD is 12 by 5. So XD is 5. Doesn't make any sense. So maybe, yeah. Doesn't make any sense. No. So it is not possible. This is, my numbers were arbitrary.
Okay.
You understand? My numbers were
Yes.
wrong, right? It could be, is it possible? These numbers. No, the triangle only will not be formed. This is too big. That is the problem. This 5 has to be smaller, no?
1.
So if it was 1 or something, then AD was 12. So that is seeming fine.
We're done, master.
That works, no?
Yes.
So then this distance is 11.
Yes.
7, this is possible, no? This 12 ka altitude is possible, no? If it's 7 aside. Yeah, it's possible. You could have a very tall triangle, right?
Yes.
So basically, I want you to remember the result that HD into AD should be equal to BD into CD, right? Now, from here, we can go on to question number 11. Question number 11 of assignment 2. Did everyone get it? Question number 11. I will open my PDF, 1 second. Wait, it is taking a little more time than expected. Is everyone getting question 11?
I've not tried it. Sir.
Okay.
The same here, so even I didn't try it.
Try it, no? Try it now.
Okay.
See it now. Now I think you know enough to do it. Can someone read out the question? My PDF is not opening. 1 second. Can someone tell me the question once?
In a scalene triangle ABC,
In a scalene triangle ABC,
let the feet of the perpendicular
feet of
from
a
from ABC to the side DC, CA, and AB.
B A1 B1 C1
Yes, sir.
PC C
Denote by A2 the intersection of the lines BC and B1, C1.
into A2 intersection of line BC and
B1, C1.
B1 C1. Okay. Okay. And similarly,
Yeah.
B2 and C2 similarly.
Yes. Let DEF be the respective midpoints of BC, CA, and AB.
DEF midpoints of BC CA AB.
Show that the perpendiculars from D to AA2, E to BB2, and F to CC2 are constant.
Prove that perpendiculars from D to AA2, E to
BB2,
PP2 and C2 C2 F2 CC2 are
are
concurrent. They are what? Concurrent, no?
Yes.
Collinear.
So concurrent.
concurrent.
Okay, okay. Perpendiculars are concurrent. Okay. Okay. So let's try to draw the figure. There are many things in it, but we will try to understand what is happening. Okay. Okay. So A, B, okay. A, B, and C. Okay. And feet of the perpendicular from A1, B. So A1, this is A1, and this is B1, and there is C1 also. C1 will be here somewhere. C1. Wait, this figure seems wrong. 1 second. ABC. Denote by A2 the intersection of BC and B1C1. BC and B1C1. BC and B1C1. That is A2. And similarly, B2, the intersection of, I will not draw that. I will just focus on this one, A2. And DEF are midpoints of BCCAAB. So D is somewhere here. BC, CA, E, and F is somewhere here. F. Now perpendicular from D to AA2. Perpendicular from D to AA2 and E to BB2. E to BB2. I need B2 also. So intersection of BC and B1 C1. So A2. So B2 will be CA and C1A1. CA and C1A1. CA C1A1. C1A1 will be this line. Okay. I need a big figure here. Wait then.
So is it possible that they intersect backward?
Is it possible that they?
Intersect behind, not in front.
It is possible. They will intersect far off places.
So, is it possible they intersect behind the points, like not in front?
Behind, I don't understand what you mean. It could be above and all.
Yeah, above.
Yeah, it is possible. So 1 second. I need to look at the question. Now my PDF I can open. Wait one second. See, sometimes what happens, no, the figure is the most difficult part of the whole thing.
Yes.
So drawing the figure is very important, and in Olympiads, when you are writing, it is okay to use your protractor and scale and properly draw it. Okay.
Yes.
So don't hesitate from using protractor and scales and all.
Yes.
This question, you have to just use your protractor, scales, and make a proper triangle with measure everything nicely 90 degrees and all correctly, and make a big diagram. Like right now I cannot show you using that, but the more you make a bigger diagram, the better it is for you.
Yes.
And don't hesitate to use your scales and all to draw all the 90 degrees and all. So because it needs to be really accurate for you to be able to understand the question. This is, by the way, a USA team selection test question, TST 2012. So what is a team selection test? You know that, right?
MOPS, right?
Huh?
So they call it MOPS, right?
I don't remember that, but I know what is a team selection test. So 30 people are selected, no, for
Yes.
the camp.
Yes.
So among that 30 people, to select the 5 people who will represent the country in the Olympiad, those people are given several tests. So this is one of those questions from that test. Okay. So
Yes.
it is at the level of IMO, or even sometimes they are slightly harder. So you don't worry about, like, you should feel a sense of achievement if you solve it. So you should try it, because then only you'll feel that sense of achievement. We'll draw a good figure here and try to understand what is happening. Right. So A, B, C, A, B, C, and we have HA1. So B to B1 this side, B to B1, A1, A to A1. This is A1, then C to C1, C to C1. This is C1, and then we have midpoint D, midpoint D of AC, midpoint D of AC somewhere here, and okay. Do you have A2 C1? A2 you want to make. So A2 was the point of intersection of B1, C1 and BC, right?
Yes.
B1, C1 and BC. So let's make our B1, C1 and BC. So it will cut here somewhere. Let's make, this is my A2. Okay. So we have A2 also, we have B1, so we have C1. We need A3. A3.
So B2.
B2 we need. So E to B2 perpendiculars from D. So we need first B2.
CA1 and A1 C1. That will be
CA1 and A1 C1. A1 C1, CA1. This is a problem again. Somewhere they will intersect. Okay. Okay, so let's try to, without drawing it also, we can think that
so you can have a point somewhere up and then
we can have a point somewhere up. I don't care where it is. I will just think about I want to prove perpendicular from D to AA2, perpendicular from D to AA2, right?
Yes.
And E to B, B2, D to AA2. AA2 is what? AA2 is this line, no?
And D is the midpoint of BC.
Correct. So AA2 is this line and D is the midpoint, perpendicular from here to this, right?
Yes.
Perpendicular from D to this is AA2, and similarly E to BB2 and all. I will not care about them right now
Yes.
because it is hard to draw the figure in my screen. So I
Yes.
want to prove that these lines are concurrent.
I think they are coming to meet at the
Uh,
center only.
it looks like it is passing through orthocenter because my figure is more or less like okay so far. So it feels like it is just missing the orthocenter by a little bit, right?
Yes.
If you guys draw accurate figures, then you will find that it will pass through orthocenter. So
Yes.
my suspicion is that D to AA2, this perpendicular line passes through H. Okay, so let's try to prove that. If we can prove that, then similarly, same logic, this will also work, no? So all the lines will pass through H, right?
Yeah.
So then they will be concurrent. So see, notice that so far we have not applied any geometry. We have just drawn the figure and we have tried to think how will it be concurrent. It looks like it will pass through orthocenter, right? Correct. So,
Yes.
so let A3 be the foot of the perpendicular from D to AA2. Let this point be A3. Okay. I will just rub off this necessary line. These lines are unnecessary right now. Okay. Let A3 be the foot of the perpendicular from D to AA2. Now AA1 is perpendicular to BC, no?
Yes.
AA1 is perpendicular to BC and DA3 is perpendicular to AA2, right?
Yes.
Correct. So what is a cyclic quadrilateral? Because of these two perpendiculars, what is cyclic?
H A3, A2, and A1.
H we cannot assume. Okay. So we can say that quadrilateral A3, A1, DA is cyclic. A3, A1, D, and A.
Yes.
Because look at this,
So equal angle.
90-90 or equal angles also.
Yes.
What is the method by which we are proving it is cyclic?
Equal angles because they are equal. The chord AD.
Chord AD is equal.
Yes.
Chord AD is subtending equal angles.
Yes.
Because this is subtending 90 here
Yes.
and this is subtending, same chord AD is subtending 90 here, right?
Yes.
So A3, A1, DA is cyclic. Now, okay, this is cyclic quadrilateral is coming. So A2,
The diameter.
what?
So A1 is the diameter and A3D is also diameter.
A1 is a diameter, yes. A3D is also a diameter, correct? No, A3D is not a diameter. 90 degrees here, no. So this is a diameter, no.
Oh yes. Sorry.
AD is a diameter and AA1 is a diameter. No.
So no,
Not,
only AD.
only AD is a diameter. Yeah, AD is the diameter of the cyclic quadrilateral. But what we want to use is power of a point. So let's see what we can say about A2 point. There is a circle passing through this four, right?
Yes.
There is a circle passing through these four like this, somehow like this, right?
Yes.
So you can say that A2 into A3, A2 point power will be equal to A2 into C1, A2 into, not C1, yes. I have rubbed off that C1, but C1 was here, no, somewhere.
Yes.
A2 C1 into A2 B1, right? That is also power, no?
So
Wait.
C1 is on the circle.
Wait. A2 A1 into A2 D. Okay.
A2 A1 into A2D is A2
A2 A2 A1 into A2D is a power. A2 A1 into A2D is a power. Now, is there any other cyclic quadrilateral also? C1. Definitely A2 will cut the circle. To C1 B1. Is my B1 point lying on the circle? Okay. The
So
problem
that's
is
90 degrees. So
hmm, 1 second. A3 A1 DA is cyclic we are getting.
B1 is not lying on the circle.
The figure is only bad. No, that is the problem. Wait. Uh,
So when I'm drawing the circle, it's not coming.
if you are drawn properly, what is happening?
So it's not coming on the circle. No.
Okay, okay. 1 second. I thought by power of a point we can do it, but wait. Maybe there is a problem. A2C1 into A2B1. A2C1 into A2B1, what is happening? A2C1 into A2B1. It feels like uh, what is this A2C1 do? I have to draw it again. Uh, A, B, C, A1, C, midpoint. We have B1, C1, and C to C1. C to C1 is also 90 degree, 90, 90, 90. And this is orthocenter H, and B1, C1, B1, this is C1, and BC, intersection point with BC. Okay, my line is becoming too big. So maybe it is slightly this side. So draw slightly more tilted line like this. This is my point A2, and A3, D2 perpendicular on AA2. AA2 is like this. AA2 D. From D, I am making a perpendicular. This is my A3, and we have quadrilateral A3 A1 DA. A3 A1 DA is cyclic. A2 C1, A2 C1 into A2 B1 to A3. Oh, one more cyclic quadrilateral we have. No, obvious cyclic quadrilateral. This is 90, no, and this is uh, what are the cyclics we have? This is 90, this is 90, no,
Yes.
right? This cyclic quadrilateral is there, no? Correct. Is there some other cyclic also that we can see?
So A, C1, B1,
A C1,
and B1.
B1,
With, yeah, A,
and
C1.
A3.
Yeah.
Can we get A C1, B1, A3 somehow cyclic? I want this to be cyclic. A C1, B1, A3. So are we getting some common chord angles or something? Because okay, Yeah, it is not very clear right now. I thought I had figured this one out. A C1 B1 A. Wait. What are we doing? Oh, wait, we know some more things, dude. What is this midpoint of the side, no?
Yes.
And A1 is this, and this one is this. So we know that D lies on the same circle, no? Because 9-point circle.
Yes. Yes.
We know that D, A1, B1, C1 lie on one circle at least.
Oh, yes.
We also know that E and F lie on that circle, right? E and F we have not even marked, right? The midpoints, right?
Yes.
So D, A1, B1, C1, that is also cyclic, no? From the 9-point circle properties, we know that this is cyclic, right?
So which one? So
D, A1, B1, C1.
yes.
That is cyclic by 9-point circle, right?
Yes.
And we have already proved that this is also cyclic.
Yes.
A3, A1, DA is also cyclic, right? A3, A1, D, and A. That is also cyclic. So,
Yes. So they all are on the same side.
they are all on the same circle also, no? Then A1, D, A, and A3. Hey, why are they on the same circle? Not on the same circle. This circle is different, no? A3, A1, DA, not on the same circle, right? 9-point circle will be somewhat like this, no? A definitely does not lie on 9-point circle, no? You understand?
Yes.
So, if we have a quadrilateral like this, this quadrilateral, we have A, A3, A1, D. This quadrilateral. This is a cyclic quadrilateral, and we also have A2. See, this A2 is cutting C1 and it is cutting B1, no? This line, right? See, this A2C1 line, A2C1 into A2B1 is equal to power of a point with respect to which point? 9-point circle. Power of A2 with respect to 9-point circle, this is.
Yes.
Because 9-point circle passes through A1, B1 and C1, no?
Yes.
And it also passes through A1 and D1. Oh, now I understand. Yeah. You understand? 9-point circle definitely passes through both, no? So A2C1 into A2B1 should be equal to A2A1 into A2D.
Yes. Because they are also on the circle.
Right? This should happen, no?
Yes.
Because A2 is the same point with the same 9-point circle, right?
Yes.
Right. A2A1 into A1D. Now A2A1 into A2D we have. A2A1 into A2D, correct. So what do we have about A2A1 and A1D? Do we have something like that also? A2,
So how will we prove that?
Uh-huh.
Uh, how will we prove D3 passes through H?
How will we prove that?
DA3 passes through H using this.
DA3 passes through H, because I want to prove eventually that H lies on circumcircle of which triangle, which circle? A3, A3, B1, C1. I want to prove that this is cyclic and H is on the circumcircle.
Okay.
So right now I'm not getting it, but this is my plan. A3, B1, C1 is cyclic and H is on the circumcircle. So if I can prove that, then DHA3 will be a straight line, because HA3 should be a straight line then. HA3 should be a straight line.
HA3 should be perpendicular to A2.
HA3 is perpendicular to AA2. So
If we show that, then
yeah, if we show that, then we are done. Fine. I will think about it a little more. I thought I would be able to solve it, but right now I'm not getting the whole. One thing I thought, if we can get this inequality, no, that A2C1 and A2B1, we have gotten this from here. Can we somehow prove that this is cyclic? So A2A3 into A2A, A2A3 into A2A, A2A3 into A2A should be equal to, for this quadrilateral I'm saying, this circle, 2A3 into A2A should be equal to, oh wait, 2, isn't that the same thing, dude? Oh wait, we have done it, no? See, this is cyclic, right? A3, A1, DA is cyclic, right? This we
yes,
proved earlier by that 90-degree thing.
yes,
So for that circle, do power of a point from here,
from A2.
from A2, A2A3 into A2A should be equal to A2A1 into A2D,
Yes,
right?
by 9.6.
But no, for this circle independently, right?
Yes,
For this circle, power of a point would look like what? A2A3 into A2A is equal to A2A1 into A1D, no?
Yes, sir.
For this circle. Now, by 9-point circle for A2, we are getting A2C1 into A2B1 is equal to A2A1 into A2D.
yes,
So these two equalities mean what? A2C1 into A2B1 is equal to this A2A1
A1 into A2D.
into A1D.
Into A2D. So it's not even.
It is A2D actually, right?
Yes,
So we are getting the equality A2C1 into A2B1 is equal to A2A1 into A1 A2D. So that means B1 C1 A1 D are, okay, that is not a useful thing, that we already knew, no? A2 A3, oh, we should have used this one, no? That we already know. I should use this one, no? I got A2C1 A2A1 into A2D is equal to
A2, A3 into A2.
A2A3 into A2A is same as A2C1 into A2B1, no? This one,
Yes,
these two. If these two I use now, then I will get what? That C1, B1, A3A are cyclic. You understand? C1, B1, A3A should be cyclic, no?
yes,
See, I have not done it very well, but you understand that is coming.
yes. So A2 B1 into A2 C1 is uh, power of point A2 with the circle AC1 B1.
Correct, correct. This is power of a point A2 with respect to this circle, and this is also power of a point with the same circle. No?
Yes.
See, what we have gotten is two conditions from two different power of a points. This is the circle, this is one circle, and this is, and one other circle is 9-point circle. And this gives us a third equality, right? Because one of the things is common. This thing is common in both, no?
Yes.
When you get the third equality, this equality, right? When you get that, you know that C1, B1, A3A is a cyclic quadrilateral.
Yes.
C1,
So,
B1, A3A is cyclic, right?
yes. So now
Correct.
H should lie on.
Now, if C1, B1, A3A is cyclic, I will draw a figure like this. A was here, C1 was here, B1 was somewhere here, and A3 was somewhere here. A3 was somewhere here. And the perpendicular was from H, right? Perpendicular was from H to A3, right? Correct. And we have
From
H,
A to A3.
and H to C1 was also perpendicular, no?
Yes.
And H to B1 was also perpendicular, right?
Yes.
So you have HC1 is perpendicular to AB, and AB, C1 lies on AB only, no? AB was like this, right?
Yes.
And B1 lies on BC, something
Yes.
like this was there.
So
HC1
we
was,
have to prove that
huh,
H lies on DA3 and DA3 is perpendicular.
correct. So HC1 is perpendicular to AB, and HB1, this is B1, is perpendicular to AC,
Yes.
right? So that means what? That means
A
that
is perpendicular.
that means that this is giving 90-degree here and 90-degree here, no? And this is a circle, right? Passing through these, right?
Yes.
Only if it is a line lying on the diameter will this happen, no? You have a circle around A, C1, B1, and A3, and from one point you are getting 90-degree, right? Two different angles, right?
Yes.
Right? Then H must lie on the diameter, no? H plus lies on circumcircle, right? Otherwise, same chord, how can it give same? It is like same chord is giving same angles, right?
Yes.
We got two different angles very equal. By the way, we also got see, this angle is also equal to this angle, no? This is same line,
Yes.
same angle. So this is the point on the circumcircle, no?
Yes.
Everyone is convinced that H lies on circumcircle.
Yes. So that's why DA3 passes through H.
So HA3 is a straight line now.
DH3. DH.
D DHA3 lies on a line because HA3A, the angle HA3A is
Is
equal
like
to 90 and is equal to 180 minus HBA. HBA.
so actually HA3A is equal to DA3A. So H lies on A3D.
HA3A is equal to D. D was where? D was the midpoint, no?
It
Here.
was the original one. Yes.
D was the midpoint here.
Yes.
HA3A lies on DA3A. Therefore, you're saying that
H lies on DA3.
H lies on DA3.
So
Because
similarly, others will also intersect.
because basically the perpendicular line was happening only if H lies on it, no? Like
Yes.
this will, if you can prove independently that H lies on the circumcircle by using this two, right? Then you
Yes.
know that this angle is also 90.
Yes.
And if this angle is 90, then DA3, then it is H is concurrent. H is lying on DA3.
So similarly, H will also lie on the other.
Similarly, H will also lie on the other two lines passing through, right?
Yes.
Right now, this is a very bad way to prove it in the sense that there are so many mistakes and all, but you understand the logic of it was this. you had some points here and all, and you had to spot cyclic quadrilaterals, right? This was your A1, this was your P1, and what we noticed was two different cyclic quadrilaterals, right?
Yes,
So once we proved that our first we proved that A3 A1 DA was cyclic, and then we knew that 9-point circle obviously has 4 points. 9-point circle has which points on it? It has D, it has A1, it has B1, and it has C1 on it, right? Correct. So we wrote two conditions from point A2. We wrote power of a point conditions from point A2 for this circle and for this circle, right? Correct.
yes,
So we wrote our A2C1 into A2B1 is equal to A2A3 into A2A, and we also wrote our condition A2A1 into A2D is equal to A2C1 into A2B1. So this and this were common, so we got this is equal to this, right? Which helped us prove that A3, okay, some mistake is there. A3, P1, C1 is cyclic.
and from that we got H lies on that circle.
And H lies on the circumcircle. H lies on circumcircle of this. And once it lies on circumcircle, then that is a straight line. Okay.
Yes.
So slightly difficult question, but this question is related to the power of a point thing. The next few questions are also power of a point. So you should try it. Even if you don't get it, it's fine. We'll discuss it. What I will do is we'll have a class on Wednesday. In case home is missing that class, it's fine. You can see the recording. I will
Yes,
send you
sir.
the recordings and all. So there's not a problem. That will be an algebra class. I was not well this week, so I have not sent us more stuff. So I wanted to send one assignment case for geometry, but I will send it soon. So algebra class, it will be an inequality class, and on Wednesday evening. So I will be ready with a little more questions and all. We want to finish up the second assignment of inequalities has 3-4 more inequalities or 5-6 more inequalities that I want to discuss. But more or less, whatever is in first assignment is sufficient for PRMO, RMO and all. So you should be focusing on first assignment only and making sure that you understand the inequalities. And hopefully with one more class, we'll be almost done with the chapter on inequalities. Okay. So I'll see you guys on Wednesday evening, same time. And whoever is not there, I will send the recording for the video. So that's not a problem. Okay. Bye, guys.
Thank you so much.
Thank you, sir.
Take care, sir.
Yeah. Thank you.